continues to burn, at least for 5 seconds. The history of flashpoint. The 9th century was the first discovery of the petroleum and petroleum product and petroleum in general, and the usage of petroleum distillate in lighting and heating instead of animal and vegetable oils. And that led to many explosions and fire-related accidents. So it was very important to know the nature of the used distillate or petroleum products to be used. Then in 1862, with the first attempt in UK Petroleum Act, which followed in 1888 by German petroleum regulations, and then they are quickly spread around the world, which make great development of many types of test instruments to reach to the full automated instruments nowadays. There are many purposes of flashpoint tests to be determined for the sample because of their importance. This is because of the fundamental reason for this requirement of flashpoint measurement is to assess the safety hazards of flashpoint of a liquid or semi-liquid with regard to its flammability, and then classify the liquids to groups if they are flammable or not. The lower flashpoint temperature is the greater the risk. The classification is then used to warn a risk and enable to correct precautions to be taken. There are changes in flashpoint can be indicated in the presence of potentially dangerous volatile contaminations or addition of another product to the main product. The classification of chemicals, including petroleum product, and helps to identify the hazards of substance or preparation. Also, flashpoint is used in shipping and safety regulations to define flammable materials. Flashpoint can indicate the possible presence of highly volatile and flammable materials in a relatively non-volatile or non-flammable materials. For example, the abnormality of low flashpoint on the test engine oil can be indicate presence of gasoline contamination. There are many facts affecting the flashpoint or the flammability of the sample. Maybe the condition under which a substance can be ignited and those under which it continues to burn, which is known as flashpoint and firepoint respectively. The concentration range over which the vapor and oxidant mixture is flammable, upper and lower flammability limits or range. These limits vary depending on the oxidant pressure and minimum oxygen concentration required for the combustion reaction. The presence of contamination, particularly if the contaminant is relatively more volatile. For example, pure ethylene glycol has a flash point of 111 degrees centigrade. However, the flash point is reduced to 29 degrees centigrade when acetaldehyde was added by only 2%. There are changes in flash point. Also, there are many, or a common example would be like ethanol and water, which change more of or in the flammability of the sample. There are many corporations to give us safety legislation of flash point, like CPSC, DOT, EPA, UN, ADR, ECHA. There are different types or different methods for flash point determination. Mainly, there are open cup and closed cup. Open cup or closed cup, closed cup, which is known as Penske-Martin, related to Mr. Martin in 1870, and this method was modified after that. In this method, the test cup was filled to the inside mark and fitted with the cover, stirred and heating. The ignition source is applied directly to the test cup until the flash point detected, according to the standard test method which we used. After that, the open cup, which is known as Cleveland open cup. In this method, the cover in case of closed system will replaced with clip, and the ignition source is passed through the cup, and by vision of flash point is the lowest temperature at which the vapor of sample causes spark or flash. To get the fire point, heating was continued after the flash point till the whole surface of the sample were burned for about 5 seconds. Flash point by the both methods were differ. The degree of flash point will differ from open and closed. Why? Because in the open cup, the vapors of the sample which can evaporate will be discarded around the environment, and there are too little vapors present. So the flash point by the closed system is more accurate. There are many methods or different methods according to the range of expected flash point, according to different standard method, which the sample may be start from -32 or up to 400 degrees centigrade around open and closed cup methods. These are the different methods of flash point determination. There are many correlation methods. Flash point method must be correlated, and there are different methods to reach to the precision. And the precision of the test method is important for assessing the correct operation of flash point instruments and quality control, and can cause and transfer help in transfer the product. Can be defined or divided into two methods. There are repeatability and reproducibility. Repeatability, this can meet by the same conditions, the same laboratory, the same operator, and the same apparatus. In case of reproducibility, there are difference in the laboratory condition, different operator, different apparatus, and maybe different laboratories. But the method must be the same or the differ according to the deviation which be recorded. Anton Paar create a mini cup which can save sample because it's used small amount of sample, and determine the flash point of many samples like isooctane, normal heptane, toluene, ethanol, octane, and diesel fuel ethanol 5%, and measure the deviation of this, and found by reproducibility for the flash point result, determined that the deviation recorded 3.2 degrees centigrade. It was found that the test results show an excellent correlation in this study within the reproducibility of the test method between both test cup size, the mini cup, and the standard test cup. So, meaning the mini cup can be good alternative to the standard test cup when only small sample amount is available. We can complete with Mr. Muhammad.
Thank you very much, Dr. Raghda, for this really nice presentation. And I'm continuing with you in the instrumental part. Let me share my screen. All right. I'd like to say that the flash point is not a fingerprint of a sample. And as Dr. Raghda said, that each apparatus can give you different results. And many studies are being used to correlate the results of the flash point for samples with different apparatus, and they are really different in terms of the flash point temperature. This is why the best way to choose the appropriate method for flash point testing is to conform to the standard method that is appropriate for this kind of sample. And let's talk about the instrumentation part, beginning with the ignition sources. We have two kinds of ignition sources. I'll let somebody. All right. The first type of ignition source is the gas flame, and the most used in flash point testing. It gives reliable results. However, there is some disadvantage of is that the size of the flame needs to be set by yourself. So there may be a disruption during the test while using the gas flame. On the other side, the electric igniter, the possible change in igniter temperature over a period of time and the lifespan of the device, and this highly affects your flashpoint measurements. And the best solution is guaranteed by Anton Paar is to use both simultaneously. Why simultaneously? Because in case the gas supply finished during the test, you have another one, which is the electric igniter automatically replaces the gas igniter, and the test is not disrupted and continuing smoothly. We have three kinds of detectors. The human eye is the most traditional detector used, and this is appropriate for the manual tests. However, when using the automatic instruments and the closed cup instruments, you cannot see the flash by your eye. The second detector is ionizing ring detector, and it operates as organic compounds burns. However, this kind of detectors is highly affected by water vapor, and this is why we cannot use it for closed cup measurements, because water vapor comes and affects the detector. This is why we use the ionizing ring detector for the open cup instruments. In the closed cup instruments, we use the thermal detector, which measures the increase in temperature caused by flash, and it gives really reliable results, and even in the presence of the water vapor. This is why we can use it in the open and closed cup instruments. The next one is to stir the sample. Sometimes we need a stirrer to keep the heating rate and to distribute the temperature all over the sample parts, and this increases the accuracy of the results, and we will find this stirrer option in the Abel method. However, before testing the flash point, we should stop stirring because the vapor needs to stabilize. For the temperature measurement, we have different kinds of temperature measurements. The first method is the mercury thermometers, and this is a really old method to measure the temperature. Why? Because of the safety concerns regarding the mercury. This is why it's phased out in some countries due to this reason. The other way to measure temperature that is used nowadays is the calibrated thermometers. However, we should guarantee that these thermometers conforms to the standard methods. And to do so, we have to do calibration for these thermometers. This is why it's called calibrated thermometers. All right. What about the samples that have volatile contaminants? These samples have very low flash points, and sometimes we need to come below the ambient conditions to measure the flash point. This is why we need a cooling system to reduce the temperature and also to control the rate in these low temperatures. The first method is to use a circulator, a water circulator, or any kind of circulators according to your temperature. And the other one is more reliable and more accurate, is called Peltier cooling method. And this is an electric device that is cooling and heating really fast rate in temperature change. And it keeps the higher control of temperature when compared to the circulators. And this link shows you how the Peltier element is a really advanced method of controlling the temperature nowadays. It's very long video, and I will not operate it all. Sorry for this ad. I know there is no sound, but I type here the subtitles, and you can see it later. The link is in the presentation. As you can see, from one side it's cooling and the other side is heating, and this kind of temperature controlling, it's a really advanced tool and used in most of Anton Paar instruments. Let's continue. For the barometric pressure correction, how about the pressure? Is it affecting the flashpoint test? Yes, it's affecting in some circumstances, like the high altitude areas. Why is it affecting? Because the test, when the test is heated, the molecules evaporate to form a vapor, and this vapor causes a pressure. This is why the pressure has a direct relationship with temperature, and it has to be corrected to get accurate results of the flashpoint. Anton Paar have various kinds of the flashpoint testers according to your application. The first one is the CLA5. All of these instruments are fully automatic, and this CLA5 instrument is used for the Cleveland flashpoint testing for open cup tests, and it measures both the flash and fire points from the range of 40 Celsius until 400 Celsius. The second product is the PMA5 and PMA500, and actually these are instruments for using the Penske-Martin flashpoint tests, and it ranges from 40 until 405 in case of the PMA5, and the modern instrument PMA500 that reaches 410 Celsius. And then we have two kinds of instruments, which is the Apple and the TAG flash points, and both of them have two versions to deal with the highly volatile, the samples with high volatile content. They are two kinds of instruments. The first one is liquid cooling to handle the samples below the ambient and down to minus 30 Celsius, and the other one is the air cooling, which uses the Peltier element and air fan to deal with samples from 10 Celsius to 110 Celsius. All right. Let's begin with the Apple flashpoint from Anton Paar. It conforms to the IP 170, which is a UK standard. And the standard method is it covers the range from minus 30 to plus 75. However, the instrument, any instrument should cover a wider range of instruments, not exactly the same range of the instrument. However, it conforms to the standard method, and the idea is to use the stirrer with the Apple closed cup test. And the ABA4 is Anton Paar instrument that determines automatically the flash point of jet fuel, solvents, and mixture of solvents, and so on. These are the specifications. As we said before, below the ambient, we need an external circulator. However, above the ambient until 110, we use air-cooled version. And the ignition is gas and electric. In case the gas supply finished, the electric igniter replaces it automatically. We have a stirrer in the Apple ABA4, and the flash detection is thermal, and we have automatic correction of barometric pressure, and this is the case of all Anton Paar flashpoint products. And we have safety concerns about the overheat protection and automatic shut off in case of any fire. And we have also the gas supply of 50 millibar of propane or butane. The other instrument is TAG, closed cup flashpoint test. It's according to the ASTM D56. And it's the same as the Apple instruments, except for the stirrer. It has no stirrer, and the rate of the heating is different than the Apple. It also uses a Peltier element above the ambient, along with the air fan. However, below the ambient, we need an external circulator to help us reaching low temperatures. The features of both instruments are a lot. Some of them are, it complies to the standard methods, ASTM and ISO, and it has one twist head, no cables needed to install the instrument. This is why the installation is very easy, and you can open and close it very easily like this without any training. We have gas and electric igniters. And we detect the fire outside the cup by thermocouple, and we have a sensor to correct for the pressure. And we have Peltier element, which is the most advanced tool in controlling temperatures. And we have automatic overheating detection and shut off during the test. We have also a memory that can give you 100 test results, and the optional software that enables you for the research purposes and correlate the results from circumstances to another. And it has an IS prevention system and really small size in the laboratory so that you can save your place or space in your benches. The next device or instrument is the Cleveland Open Cup Flashpoint Test, ASTM D92. And we have in Anton Paar the CLA5, which is automatic flashpoint tester, and it measures not only the flashpoint but the fire point in open cup tests, and it's used for samples that is highly viscous and flashpoints having a flashpoint above 79. This is why we see that it covers a wide range of temperatures up to 400 Celsius. And also our instrument solves the problem of the silicon content. The silicon content in samples affects the flashpoint test. However, in CLA5, it makes correction for this and give you accurate results. Even the silicon content is higher than 1%. These are the features and specifications of the Cleveland CLA5. We have automatic correction of the pressure, and all other specifications are the same except for the ignition, which is gas, and the detector is ionization detector, not thermal. The features are the same as Apple and TAG, except for it has more points of calibration, 21 calibration points, and it has jog shuttle operation, which is easy handling and give you some colors in the screen to show you the state of the instrument, if it's cooling, if it has error, if it's measuring. And also it has password protection and statistical analysis for research purposes. and the FPP-net software is optional, and also it's easily handling, and you can put USB stick to the instrument and import to Excel sheets to save your results. The next one is Penske Martin, and when we talk about Penske Martin, we should talk about Anton Paar. Why? Because Mr. Penske, who invented this method, is the owner or founder of the Petrotest company, which is now called Anton Paar Protec. So Anton Paar have more than 100 years of experience in the Penske method. And this is an extension of Mr. Penske, the initiator of the method. This is why we come to this instrument, PMA5, which is a full automatic instrument that deal with different kinds of samples, such as the distillate fuels, the residual fuel oil, and the biodiesel. And also, there are different procedures. Each procedure deal with a different type of samples. And these are the specifications of the Penske Martin closed cup PMA5. It reaches temperatures up to 405 Celsius, and the ignition is gas and electric, interchangeable during the test, and the heating is according to the standard method, and the steering is the same. The cooling is really fast by the highly efficient fan, air fan, and we have the thermocouple for flashpoint detection. And we do calibration for temperature and barometric pressure as usual, and as any kind of instruments in Anton Paar flashpoint testing. We have safety standards for the overheat protection, automatic shut-off, and fire extinction system. We have 3 USB places to use it for data export and import. And also we have gas supply for the test flame, 50 millibar of propan or butane. We have fire extinguisher in case of any fire happening. It's 6 bar to 12 bar of nitrogen or carbon dioxide. And the power supply is 115 volt, and the dimensions is as you see here in the specification. And this size is really appropriate for your laboratory space. And the features are the same as other Anton Paar flashpoint testers. The most important is no need for training. It's really easy to operate and install. It's one twist head. The memory is higher than the previous instruments. It's up to 1,000 tests and 20 operator names and 100 sample names and 21 test methods. Similarly, you can use the statistical analysis, and you can generate the results into an Excel sheet, and it has also automatic fire extinction system. And I wanted to end up with the most modern cost-saving flashpoint tester in the world, which has been initiated recently by Anton Paar. It's full automatic instrument, and it also conforms to the ASTM D93 for the Penske Martin closed cup flashpoint testing. Why it's cost saving? Because the electric igniter in this instrument is covered by ceramic coated, which gives him more than 10 times increased in lifetime. So if the old one is lasting 1 year or 2 years, this one will last for more than 10 years. Also, the cooling speed is really fast, and the cooling speed is reduced by more than 20%. And this is really nice for saving time between the samples. If you measure one sample, you don't have to wait too much time to measure the other sample. Also, you have fire detection by infrared sensor, and the gas flame detection by FID. And also we have mini-cup available, such as the calibration case study that Dr. Raghda showed before. We have excellent correlation between the results, and when using the mini-cup, you save your samples, and this can be used only in case your sample supply is limited and you want to save it. The stirrer speed calibration. We have calibration not only for the temperature and the pressure, but also we have calibrations for the movement. I'm sorry. All right. We have calibration for the movement of the igniter itself, and also we have automatic motor-driven multi-function heads, include igniter system and the stirrer motor, no open or visible cables. And you will see in the video after the session how these instruments operates automatically. And these are the specifications of the instrument. It reaches more than 400 degrees Celsius. It uses gas and electric cost-saving igniter, and the heating according to the method defined, and the steering the same to control the heating rate, and the cooling is really fast by a high efficient air fan with boost cooling mode. And this mode enables you not to wait too much time between the test samples. The detection is thermocouple, and the temperature sensor is PT100, and we have automatic calibration of temperature and the pressure, and also the movement of the igniter. We have overheat protection and automatic shut off. We have 5 places for USB so that you can do data export and import. And I will leave you with this really nice video. Don't worry for the voice. I have the subtitles in the video, and you will have the link later. You can use it and see it by yourself. This is the PMA 500 Penske Martin. It's a really time saving of up to 10%. The operation is really easy. You just put your sample inside the cup and insert the cup into the instrument, and that's it. And you press the button of start, and that's it. And you wait for the result. Start. Measure. That's it. No need to put estimation for the flash point and set some parameters to the instrument. It's fully automatic, and the head is moving automatic also. And it conforms to the all standard methods of Penske Martin. The electric igniter, as we said, it's coated with ceramic, and it has more than 10 times lifetime. And the advantage also of this instrument that the touch screen is really big. It's 7-inch touch screen, and this is the most modern Penske Martin flashpoint tester in the market. And here we come to the end of our presentation, and now it's time for your questions. Please, if you have questions, you can type in the chat or raise your hand and open your microphone and talk. Thank you very much for attending. And now for your questions. Anybody have any question? Dr. Hisham, could you please open the microphone and talk? Yes, Mr. Hisham, could you please unmute the microphone from here and talk because we don't hear you. Thank you.
Okay. Hi, everybody.
Hello, Dr. Hisham. How are you?
Fine, thank you.
Thank you.
My question, can we use any special liquids for cooling to reach -30?
Sure.
Except water.
Sure. I think there are different, water cannot be used in this kind of range of temperature, and there are different kinds of liquids used. And Dr. Raghda, do you have any experience with the type of liquids used in this very low temperatures?
Yes, in case of low temperature, it's preferred to use the ethylene glycol because it has a wide range of freezing. But water, it will be iced. It can't be used.
For isopropanol, can we use it?
Isopropanol, the ethylene glycol is more range. And we maybe make a mixture with ethanol glycol and water. It's the preferred.
Okay.
Isopropanol may cause corrosion, may cause any distribution in circulating system, but ethylene glycol is safe.
In case we have isopropanol, does it affect the instrument or not?
Sorry, can I ask something? Dr. Hisham, do you mean the isopropanol as a cooling liquid or as a sample that should be measured?
No, as a cooling liquid.
Oh, yeah, okay.
Isopropanol as a cooling liquid maybe make any problem in the apparatus by maybe corrosion, maybe anything. The alcohol was a safe solvent and a safe to the cooling system. And has a wide range of it may be reached to -60. Okay, or what? There are any questions?
Thank you. That's clear.
All right, thank you, Dr. Raghda, for your answer, and thank you, Mr. Hisham, for your question. And
thank you for the lecture.
Thank you very much. And could you please have any other question? Anybody have any question? Could you please raise your hand or type in the chat box here? All right, it seems there is no questions. Okay. In case you have any question later, you can contact us. Dr. Raghda is with us with the WhatsApp group, and you can ask anything, anytime, by sending to email or in the WhatsApp group. And we are really happy to answer your questions and inquiries. And I really thank you, Dr. Raghda, for the informative presentation and really nice presentation. And hope I see all of the attendees next week for the last lecture in the training, which will be in the topic of viscosity measurement, again with Dr. Ala Ghanem, who give us the really nice presentation and talk about the rotational viscometers. And this will be the end of our training program next week, next Wednesday in 10 a.m. And I'd like to thank you all for attending in early time before the session begins. And please, to guarantee your attendance, please answer the quiz that I will send to you later after the session. And if you have attended any session in the past and you have never answered the quiz, please do the previous quizzes in order to get your certification. And I'd like to remind you that to get a certification of attendance, you have to attend at least 3 sessions and pass the quiz of these sessions. Thank you very much, and thank you, Dr. Rada, again, and see you next week. Thank you so much. Goodbye.
Thanks.
Thank you so much.